Alright, now we're going to do question 4 from the 2003 form. A particle moves in the xy plane so that the position of the particle at any time t is given by x of t equals 2e to the 3t plus e to the negative 7t, and y of t equals 3e to the 3t minus e to the negative 2t. It says find the velocity vector for the particle in terms of t and find the speed of the particle at time t equals 0. To find the velocity vector, you must find the first derivative of x and the first derivative of y. The first derivative of x is 6e to the 3t minus 7e to the negative 7t. The first derivative of y equals 9e to the 3t plus 2e to the negative 3t. The form you have to write the velocity vector is this. So this is your velocity vector. To find the speed, you must do the derivative of x squared plus the derivative of y squared. And it says that it wants it at t equals 0. So we're going to plug that in, and you end up getting negative 1 squared plus 11 squared, which is the square root of 122. Now it says find dy dx in terms of t and find the limit of t approaches infinity of dy dx. dy dx is our slope, and the slope is dy dt over dx dt. So we take our derivative of y from this problem, and we put that on top, and then we have our derivative of x, and we put that on the bottom. Now it says find the limit as t approaches infinity of dy dx. So we're going to plug infinity in for all t's, and we're going to get 9 over 6, and that simplified is 3/2. C asks, find each value of t at which the line tangent to the path of the particle is horizontal, or explain why none exist. In order to do this, we have to find the first derivative of y, set that equal to 0. But because 9e to the 3t plus 2e to the negative 2t is greater than 0, for all values of t, none exist. Now we must find if there are any vertical. We need to set the derivative of x equal to 0 and make sure that the derivative of y does not equal 0 for that value of t. So we're going to do 6e to the 3t equals 7e to the negative 7t. And then we get e to the 10t equals 7/6. So t equals 1/10 natural log of 7/6. So we have, that is the value of t at which the line tangent to the path is vertical.